We continue here with the introduction of Module 6, and now we turn to Section 4.4, in which we're going to learn how to solve now linear differential equations with constant coefficients, but now where they're not homogeneous. There's some function that appears to the right of the equal sign, or that appears without being multiplied times y, or one of its derivatives. So we're going to lean on the fact that the general solution y is going to be equal to the solution to the homogeneous problem plus a particular solution. So we know that we can find this homogeneous solution. That's what we did in section 4.3. The question is, can we find this yp, this particular solution? In order to find yp, what we're going to do in this section, we're going to learn a different method in section 4.6. But for now, what we're going to do is make an educated guess and guess that it is of the same form as the function g of x. So again, if I have, here's some examples. If I have g of x is linear, say 2x minus 1, then I'm going to guess that yp is also linear. But I don't know what the coefficients of my linear solution might be of my yp. If it's quadratic, then I'm going to guess that yp should be also quadratic. If it is a trig function, then I'm going to guess that it is some combination of trig functions. If I have x times e to the 2x, I have a linear function times e to the 2x, so I would use then a linear function times e to the 2x. And if I have summation, I can use, so if I have e to the x plus cosine x, then I'm going to make a guess for e to the 2x, e to the x, that is a e to the x. And then for cosine x, I'm going to make a guess that it's going to be b sine x plus c cosine x. There are more of these, well, let me go back up, of these examples in table 4.1. I see that right here it's not going to show very well, but page 144 in table 4.1 gives you more examples of educated guesses for this yp. And let me move this around. What we do then, once we make a guess for yp, is that we substitute that yp equation into the differential equation, and we try to see if it satisfies it. And hopefully it does, and allows us to solve and understand what a and b should be, or what the constants, in this case a, b, or c, would be, so that yp truly does solve the differential equation. Now, there's a subtlety that can happen, and it is that, suppose that I have solved my differential equation and somehow this is my homogeneous solution. So notice that e to the x appears here and e to the 2x appears here. And then suppose that g of x, say, has the form of e to the x. Well, as you can see, that's exactly the same as one of my solutions, or part of my solution in the homogeneous solution. The same here, I have e to the 2x, which you can see appears here. Well, then my guess is going to be a little different. I'm going to take my normal guess, which would be a e to the x, and multiply it times x. And in this case, again, I'm going to have a linear function times e to the 2x, but since e to the 2x appears already, I'm going to multiply it times x. And you can see more of these, more about this, these examples if you see a form rule for case 2 in example 11, pages 147 and 148.